So like I said, we're going to be going over the periodic table for today. So you should have your note sheet that looks like this. And I'll zoom in just a moment. Some of this is review, and some of it is going to be new information. Everyone can see that, right? Okay. All right, so when we look at the periodic table of elements, we know that elements are found everywhere. We learned yesterday that there are how many that are consistently found in living organisms? How many are consistently found in living organisms? 6. What were the 6 that were consistently found in living organisms? Oxygen. Find it on your periodic table. Oxygen. Nitrogen. Hydrogen. Carbon. Calcium. And phosphorus. Any questions about that? All right, so then let's begin to just label information on our periodic table just so that we're familiar and remembering what everything is. So we do remember and understand that these letters on the inside represents what again? Element symbol. Because it comes from a Latin word. And phosphorus is not a K, it's potassium. All right, so that's the element symbol. We do understand that the smaller number in that box is what? Atomic number. Which also equals the number of what? Nope, these are atoms. Protons, very good. Atomic numbers equals the number of protons. We also want to understand that this larger number, and I'm going to put it down here, larger number is the atomic mass. And the atomic mass is equal to what? Not electrons. It's the heart of it, not just the neutrons, but what? It is the nucleus, but what's in the nucleus? Look at your notes if you don't remember. Don't just yell out anything. Protons and neutrons. Thank you so much, Emmanuel. And protons, though. So when you look at your pictures from the other day's notes, you will see that in your nucleus you said there were protons and neutrons. So if the atomic mass is the mass of the nucleus, then it must include what's in the nucleus, which are protons and neutrons. So far we have the element symbol, we have the atomic number, which is the number of protons, we have the atomic mass, which is the number of protons and neutrons. How do we figure out the number of neutrons? Subtract what? We don't divide anything. If we subtract the atomic mass from the atomic number, we're going to come up with a negative number. Atomic mass is larger. Subtract the atomic number from the atomic mass because we need to get rid of the protons here so we are left with the neutrons. Does that make sense? Okay, because that's elementary math, so you want to make sure that makes sense. What atomic structure are we missing? Subatomic structure are we missing? Electrons. So we're going to put a little star here and say the number of protons equals what? The number of electrons. And we can't pretend that the elements are organized so randomly. Think about the electrons, electrons, electrons. Families, similar properties are found where? Vertically. Where do you see the word families on your notes? Groups. Groups are also known as families. They're found how? Families, similar properties are found vertically. Does vertical mean side to side or up and down? up and down. So in case you don't know that, you might want to put a little arrow up and down to remind you. So is my purple, my pink showing me families or groups, or is my purple showing me families or groups? Purple. So when we're looking at them, we're looking at these. All of your elements that are listed as this are considered to be in the same what? Family, also known as group. So families, similar properties are found vertically. They have the same type of properties that are going to tell how they're going to bond because they're in the same family. So we're going to number them. I'm going to number it in pink. That's what I wrote in. 1. So this is group 1 or family 1. This is group 2. Before we label these, we need to point these out that these are transition metals, which means that they do not always follow the rules that we're setting aside here. These rare metals down here, your lanthanides and your actinides, they actually were pulled out of here. So if we place them back here, it would make the periodic table about 4 pieces of paper long so that we can fit these inside. So because these are very rare, they're just put to add at the bottom of the periodic table, but they do still belong up in here. But the periodic table would be longer, so we placed it like this to make it just a nice type of box type thing. But our transition metals, this would be family what? 3, 4, 5, 6, 7, 8, 10, 11, 12, making this one 13, 14, 15. I'm going to explain to you in a moment why I'm underlining the ones place. So families, similar properties are found vertically with the same, it said another word, valence, with the same valence electron. So if we look here, it says groups A, 1 through 8, that would be 1 and 2, and 13 through 18. These are considered groups A. This is B because they do not follow this rule. That's why I have that down here. Transition metals do not follow the rule that I'm about to tell you up here. So families, similar properties are found vertically with the same valence electrons. So it says group A, 1 through 8A, or 1 through 2 and 13 through 8 equals the number of valence electrons. Valence electrons are the number of electrons in the outer or last shell. And above shell, I'm just going to write the word orbit so you know what I'm talking about. And that's important because that's going to determine the chemical properties or how it bonds. Why is that important for biology? Because elements are in our body, but they bond with other elements to create other things like proteins, enzymes, things like carbohydrates, things like that. And they're in the food that we eat so that they bond and be able to give us strong bones and strong teeth. So that is important. That's why we're learning this. But this information is important because it's going to determine how they bond, just like you and your family. The family that you're in is going to determine how you bond with other people. For instance, you're not going to marry and date your cousins or your brothers or your sisters. Um, that's important to know. All right, so families, similar properties are found vertically with the same valence electrons. Then she says a period is just a term for the row. They have the same shells where the electrons go. These are the shells or the orbits. Our periods are found this way, which is what? Horizontal. I'm going to put that in purple. So all the way across here, hydrogen and helium is period 1. From lithium to neon is 2, and then going down, so on and so forth. What do our shells or our orbits hold? Electrons. Remember from Jimmy Neutron and your picture that you drew the other day in class for your notes, I showed you that your orbits or your shells were for the electrons. Shells or orbits are also called electron cloud. Or you may see it referred to as energy level, because it's going to determine, once again, how it's going to bond. You see how the song makes sense now? The song tells us the first 20 elements, and it tells them how they're positioned by families, what those families mean, and what those rows mean. All right? So now we're going to take this information and we're going to apply it to the back to give us a better understanding, so that when we come back to school the next day, we'll be able to understand how this actually works. Let's flip our papers over. There are 2 types of illustrations for an element. One is called a Bohr model. The other one is called the Lewis dot diagram. We're going to start with the Bohr model because this is the one that when you see this type of thing on what? Jimmy Neutron. This is representing almost like a 3D type model of an atom, elemental atom. And we're going to take this and make a 2D dimension, a two-dimensional picture, and understand what everything is here. Once again, like you saw in your notes the other day, this was a 2D dimension, but it'll give you a better understanding of what that is actually showing us. So let's see here. Let me zoom in. All right. So a Bohr model is a model of an atom displaying the nucleus and the amount of, we're looking at the atomic structures, so it's going to be and the amount of protons, neutrons, and the number of shells with the correct number of what in each shell? What goes in the shells? Electrons. So your Bohr model once again shows the total element, everything that encompasses the element. It's a 2D model. So far, so good. All right. So to draw it, we're going to draw it out. The first thing we do is we write the symbol name. What's the symbol, element symbol? What's the element symbol for sodium? Huh? Hey, that's sulfur. That's silicon. Na comes from the Latin word natrium. So we have sodium. Then it tells us in your notes right here that it shows the amount in the nucleus, the amount of protons and neutrons. How many protons does sodium have? Raise your hand. Messiah. 11 protons. So we symbolize it as with a P and the number 11. How many neutrons? I should probably say that your atomic mass should be rounded to the nearest ones place. 23. That's the atomic mass. Brianna. 11. 23 would be atomic mass. So what's the actual number? 23 is the atomic mass. So what's the number of neutrons? 12. That would give us 23. All right, so far we have what's this called in the center? The nucleus, because it's showing us the number of protons and the number of neutrons. Now it then says it also shows us the number of shells or orbits with the correct number of electrons. First we must put the shells. What on the periodic table tells us how many shells are for an element? How many energy levels, or how many orbits it has? What do we need to be looking at, Brianna? The rows or the period. So what row or what period is sodium in? Row 3. So how many shells should it have? 3. So we need to put 1, 2, 3. Then we need to put the correct number of electrons in each shell. Now, we know that the last shell contains what type of electrons? Valence electrons. Very good. How many valence electrons does sodium have? Where should we look on the periodic table? The what? The family, the group. So what group is sodium in? 1. So how many valence electrons should it have? 1. So we can go ahead and place 1 there in the last shell. But it doesn't just say the number of electrons in the last shell. It says in each shell. So how many should it have total? 11. Because why? Protons. And I'm just going to give you the rule. The first shell always contains 2. 2 is the maximum of the first shell. Each shell can only hold 8. So how many should the second shell get? 8. 8, 9, 10, 11. So 1, 2, 3, 4, 5, 6, 7, 8. It has to be 8 because the last shell only can have 1 because that's the valence electron. The first shell can only have 2. What's left? 8. Yes, it does. We have 8, 9, 10, 11. Questions for that one? We'll do potassium together, and then I want you to do hydrogen by yourself. Raise your hand and tell me the element symbol for potassium. Justin? K. What do we need next? Disha? Not the atomic number. What does the atomic mass entail? Protons and neutrons. So we need to actually put the nucleus. So how many protons does it have? 19. How many neutrons? 20. $39. Thank you. The larger number, is that correct? We have to subtract it. 39 is the what? The atomic mass. So we must subtract 19 from 39, and what do we get? 20. Make sure you guys are speaking up. If you hear somebody say something that doesn't sound right, you gotta make sure you fix it. All right, what's coming next? Stefan. The shells, very good. The number of shells. How many? Where should we look to know the number of shells? Joy. To Darren, help her out. The row. Is that true? Okay. So, Joy, what row is it in, or period? It's in the first row of the first period. Is that true? No. What row should it be in? The fourth row. Remember, rows are found horizontal. Periods are found horizontal. Groups or families are found vertically. So how many shells should it have? 4. So 1, 2, 3, What do we need to do next, Jemiah? We already did that. What are those called? Read your notes up here at the top. Electrons. Okay, so we need the number of the total correct electrons. Where should we start? The outer, because we know how to figure that out. What are the outer shell electrons called? Valence electrons. Where do we look, Aisha, to find out how many valence electrons it has? So where do we look? Look at your notes. It tells us. Where do we look? What are those things called? What is that called, though? Stefan, help her out. Nope. We're looking for valence electrons. Tim. Look at the group number. Families, with some of the properties, are found vertically. What group number is potassium in? 1. So how many valence electrons should it have? 1. How many did I tell you how many total did I tell you can go in the first shell?
2.
Only 2. So right now, how many total electrons do we have?
3.
We only have 3. How many do we need?
19.
19. Each shell's maximum after that is 8. So how many can go in this second shell? 8. It doesn't jump to another shell until it's filled up its maximum. So how many do we have right now? 11. So we're at the third shell. How many can go there? 8. Does that give us 19? 8 plus 8 is 16, plus 2 is 18, plus 1 more is 19. Is that done? Work on hydrogen on your own for a moment. Take that long. All right, Nakaya, tell me my first step. Walk me through this entire one, which is H. Zero. Because our atomic mass is what? 1. Now what, Nakaya? How many shells? 1. Is that its outer shell? Yeah, because it's only 1 shell. How many valence electrons? 1. Is it done? Yep. All right, so this was the most difficult one. We're going to move on to the very easy one. I mean, it was the most difficult, so if that wasn't difficult, then this one should be really easy. So, yes. So this one, again, shows us the whole element, everything that encompasses the element. The Lewis dot diagram is only interested in the element and how it can bond. So it's not going to show the whole thing. What do you think it's going to show if it's only interested in how it can bond? Nope. What is it? Look at the front of your notes. What thing represents how they bond? Why is that important? Isaiah. What type of electron? Valence electrons. So the Lewis dot diagram is a simplified model to show the arrangement of valence electrons for an atom. And in parentheses, I'm going to put element. And I just gave you more lines in case some of you write bigger. For a reminder, what are valence electrons? Where are they located? Outer shell or last shell. Or orbit. So, for example, sodium. First thing you need to do is write the element symbol. What's the element symbol for sodium? Na. What did we say it's going to show? Valence electrons. Where do we look to see how many valence electrons sodium has? But where do we look? Don't even pretend like we don't have what's over on the left side. The row, the family, the group. What group or family is sodium in? First one. So how many valence electrons? One.